Okay. We should add an additional term to our NPV. Who can tell me what is the term that we should still add to this expression? So we were calculating the net present value at year 8. Okay. And we said that first we should account for the investment at year 0. And since it's a cost, it's minus I0, which is here minus 20,000. We have seen that for each year, the combination of income and cost will give us $3,800. So plus $3,800 times the summation. But what should we add also to these terms? What is the missing term? Who can tell me? What do we mean by salvage value? You know that at the end of any project, okay, the machine is not operating anymore, but it has a certain economical value. You can sell it, okay? So this is why we say whenever we compute the net present value at the end of lifetime, we should add the salvage value, which is $1,500 for machine A. So plus 1,500. But of course, since the salvage value is paid after at the end of lifetime, so we should divide it because we want the present value. We should divide it by 1 plus A to the power 8, which is the lifetime of the machine. Okay. And now, if we want to calculate the IRR by iteration, by iterative procedure, we should do some trials. Okay. So we can construct a table and say for different values of IRR, we will compute what is the net present value. And the IRR will be obtained when we can confine, if you want, the calculation between two discount rate, for one for which NPV is negative and one for which NPV is positive. So in general, we can start, for example, with a value of a mid value of, let's say, 10%. So for example, if we replace in this formula A by 10%, we'll get the net present value equal to $972. So since we got a positive result, what should we do with A? We should try a larger or a smaller value of A? Who can tell me? If you want to investigate another value, what will happen when we increase the discount rate in general? A larger discount rates means that we have a higher risk. And with higher risk, we expect lower NPV. So to reduce the value of NPV, sorry, so this is here.
We should increase A.
Yes, we should increase A. So here, just here it's A, here it's A, and here we are calculating the NPV, okay? So this is the net present value in dollars. So now we can try a larger value for A. So let us try, for example, 11%. If we do the calculation for 11%, we will get a value still positive, but now we are very close to zero. So now it's nearly $57. So we are close. Okay, now we can take 12% if you want. So if we take 12%, then we'll get a negative value, which is minus 5.17. Okay. So we are very close, if you want. We are very close to the actual value. If we do it on the calculator, we can obtain nearly what is the value for the discount rate. So the discount rate is nearly 11.3%. So the internal rate of return for this project is 11.3%.
Excuse me, Professor?
The internal rate of return for this project is 11.3%. Is it a good rate, do you think? An IRR of 11.3% is good? If I tell you, comment on the result, then 11.3% is acceptable, but not very good. Okay, because the range of discount rates that you can work with should be smaller than 11.3. And 11.3 will just give you a net present value of 0. So to get a high return, you need a much smaller A. And for example, here, if I ask you, what is the discount rate for which the CER, so for which the CER is larger than 30%, for example. So for which you can start to gain 30% of your investment, then you need, for example, here at 10%, if we do the CER, so CER at 10, at a rate of 10%, it's equal to 972 over 20,000. So it's less than 5%, which is low. So we need to reduce much more A. And you can try, for example, A 5% and check for the CER. So this value is not very encouraging for machine A. Okay. Of course, maybe if we had a longer period, if the lifetime was larger, for larger lifetime, the performance will be better because we are able to gain a high amount per year. It's not bad. Okay, so if we have some extra years of lifetime, the situation might be better. But here we are limited with 8 years. This is why this option might not be very viable since the cost is really high. Okay, so let us now perform the same analysis for machine B. So for machine, yes?
Can you repeat, please, why the 11.3 is acceptable, but it's not good?
Yes, of course. Okay. It's Hilda.
No, Batul.
Batul. Okay, Batul. Look, in general, the internal rate of return will tell you what is the range of discount rates you can work with. Yani, if you get 11.3%, this means that for any discount rate between 0, okay, and 11.3%, your net present value at year 8 will be larger than 0, okay? But if you want to go and invest in a project, will you do it if you just get 0 at the end of lifetime? And if I tell you at the end of lifetime, you will just have incomes equal cost, will you invest? Batul, do you hear me?
Yes, can you hear me?
No, I can. Now I can hear you. So would you invest if you just get NPV 0 at the end of lifetime?
No.
Okay, no. So that's why you will say, I have to consider a discount rate much smaller than 11.3 if I want to gain a high amount. And if, for example, if you set in your mind that I want to earn at least, let's say, I want to have gains of 30% to consider that my project is profitable. So what should be your CER? Let us do the calculation together. Okay, so if you do 20,000 times 30%, okay, so you need to gain at the end $6,000. Okay, you need to gain $6,000 at the end of lifetime to consider that your project is profitable. Okay, so let us check if this is possible. First, if you want, we should do some trials here. This factor here can be calculated and can be computed mathematically. So we have the following. If you don't want to use your calculator to calculate the summation, you can do the following. You have the summation from 1 to n, which is 8 here, okay, of 1 over 1 plus a to the power I. This is a geometric series, okay? So mathematically, you can find the corresponding expression. So it's equal to the following. You have this term is equal to 1 plus I to the power n. Here the number of years is 8. So it's 1 plus a to the power 8 minus 1 over a times 1 plus a to the power 8. Okay, so for any value of a, you can compute this summation. Okay, and if you set that you want the CER to be 0.3 which means 30%, the NPV, as we discussed, should be $6,000. So you can put the following equation. I want the NPV to be $6,000. So it should be equal to minus 20,000 plus 3,800, which is the amount that you are gaining per year. Okay, so this term I will call it the summation S. So plus 3,800 times S plus the salvage value, which is 1,500 over 1 plus 8 to the power 8. Okay, now since you had for 11.3%, you had a NPV 0. So you should try much lower values of A. Okay, and if you want to have an idea if this CER is possible or not, what is the best scenario? The best scenario is that you don't have effect of time. Yani, if you are very confident, and let's say in future, and you consider that I don't have, A is never 0. Okay, because at the end, when you want to decide if I want to go through this project or not, you know that if you put your money in any other project or in the bank even, you will get a certain interest. Okay, so it's never possible. If you want A equal to 0 will never happen. But if you want to if you want to consider the maximum possible profit, okay, it is the case when you don't take into account A, because you consider that with time the value of your money will not change. You can do this just to take an idea. If I don't consider any reduction of money value with time, if I can reach 6,000. And you can do this in a very simple way. Each year you are earning $3,800. Okay, so you say if I don't consider the fact of discount rate, so I consider that the value of my money is not changing with time. What is the number of years, or with this number of years, which is 8, what is my maximum possible gain? You can say, if I don't consider time effect, I can per year I have the following. I have per year a gain of $3,800. Okay, and for 8 years, then I will have minus 20,000 plus 8 times 3,800 and plus 1,500 over 1 plus A, or here we are not taking A into account, so it's just I can buy and I can sell it at $1,500. Okay, if we do this calculation, can you do it please, Batul, the calculation? Guys, do you hear me? Can anyone please do the calculation to see what will be the net present value if we don't consider the time effect?
Professor, it's 11,900.
Okay, 11,900. So a CER of 30% is possible, okay? But it is possible if I take A 0. So if I take A 0%, okay, the net present value will be $11,900. And if I take A 11.3%, okay, I will get 0. So of course, the discount rate that I should have in order to get 6,000 is in between, okay? And I can do some trials, some calculations to see what is the value. And if I check, for example, for 5%, okay, if 5% is close to 6,000, this means that when my rate is 5% and lower, I can expect to have a CER larger than 30. And this value, Batul, is really small. Yani you have a restriction. You should work in countries, if you want, that are relatively safe, okay? Because a small discount rate will limit your options, okay? Because you are considering that the cost of your money is only 5%, while in general, for a lot of investors, they consider that to go through a project, I want to have the interest rate might be larger than this. So I will not opt for this because my range is really limited, okay? So I am not, whenever you have a small range of possibilities, this will limit your project, because for any value larger than 5%, let's say, you will not go and invest in the project. While if you have a large IRR, this will tell you, for example, that if A is smaller than 10%, I can invest. So you have a much larger flexibility. This is the idea. So larger is the IRR. You have a wider range of discount rates for which you can have a good profit that is acceptable. And that's why we try to increase the internal rate of return as much as possible, because 11% as internal rate of return means a much smaller rate to get a good CER. And this will limit my investment to only discount rates between, let's say, 0 and 5%. And for any other larger discount rate, which is my cost of capital, it will not work. And in general, my cost of capital, we already have taken an example, can be 7, 8%. So values of less than 5 are not good for me. Okay.
يعني professor.
No. Yes.
بس like a small recap, the discount rate were 5%. يعني أنا الكوست تبعولي ما بده يتخطى ال initial cost, maintenance cost ما بده يتخطى 5% من initial cost.
No, Karim, it doesn't have any relation. It doesn't have any relation. Look, the idea is the following, okay? When you want to invest in a project, yeah, just let me, I will do a recap. Okay.
Yes, it would be great.
Okay, look, when you want to invest, there are several numbers that you should take into consideration. هلا percentage of maintenance ما خصه أبدا. This is the percentage of the initial cost. يعني أنت, they told you إنه depending higher the maintenance will be proportional to the cost of the machine, because a higher cost means the machine is more complex and it might require more maintenance. So here they gave us the maintenance as a percentage of the investment. It doesn't have any relation with the discount rate or with the internal rate of return. Okay.
Yes.
The discount rate is the following. You have $10,000. Okay. you can tell me if I want to decide if I want to invest or not. You say, what can I do with this $10,000? The first option, I can put it in a bank. Okay, so if I put it in a bank, I will gain money with time, because each year, for example, let's say per year, okay, you get
6%.
5%. It depends on the bank. Okay, you have a certain percentage. And or if I invest in the market, let's say I have a parallel job in the market and I am able to gain, for example, in the market, I am able to gain, let's say, 8% from my capital. So this means to be encouraged, when you want to go through your project, okay, you will say that A is based on these two. Okay, so if I am debiting, if I'm taking from the bank money and I want to pay an interest rate of 5%, this means that with time, okay, the money that I have will not have the same value to present, because each year I should pay a certain percentage as a loan, or I should consider that I lost 8% that I can gain in the market. Okay.
No,
So
missed
I should
opportunity.
compensate for this. I should compensate for this. So I consider that after 1 year, let's say if I consider the interest I should pay for the bank is 5%. So in 1 year I should have let's say larger gain in order to compensate for the rate that I should put. Okay. So this is the
Yes,
idea.
Professor.
Whenever I have, this is called the cost of capital. I have money, and this money can be of profit if I put it in the bank or if I invest it somewhere else. Okay, that's why when I want to consider a discount rate, it should be based on the amount that I am expecting to gain, if you want, in another project. Or if I am taking a debit, I should consider the interest of the bank. This is why in general A, okay, I have A will depend on these two factors, and I can calculate A. Okay, but now when I want to decide if I go through the project or not, I want to compare the rates, the discount rate that is imposed by these factors, with a number which is called the internal rate of return. And what is the difference between the two? Okay. If I tell you you have A, if you decrease A, if your discount rate is smaller, this is in your favor. Why? Because if you have an option in the market to gain only 2%, okay, then your project will have a better chance to be a favorable option, since it will just have to consider a discount rate of 2%. Because larger the discount rate, lower will be the value of your money when you get it back to present. Because all your income, all your incomes and costs are divided by 1 plus a to the power I. So of course, it's not good for you to have a large A. So if A is large, this will be more challenging. You should gain much more money to be able to have a profit when you calculate the net present value. So a larger A is not in my favor. Okay, it's not in the favor of my project, because I need to expect more income, okay, in order to ensure, let's say, a certain profit when I calculate the net present value. So for the discount rate, for the cost of money, it's good if I can have a low value. Okay. Now, what is the internal rate of return? The internal rate of return is all possible values of A for which the net present value is larger than 0. Okay. So it will give me all possible discount rates for which NPV larger than 0. This is why it's good to have high internal rate of return. Because if I tell you, if A is smaller than, for any value smaller than 20%, you will gain. You will gain money. And if I tell you, on the other hand, A should be smaller than 10% to gain money, what is more challenging for you? The smaller range, because you will be more limited. And you should have A smaller than 10% to gain. While if IRR is 20%, you have a larger option. So even if your cost of capital is high, even if A is 15%, which is more challenging for you, you can still gain money and get profit from the project. Okay, so it's good to decrease A in order to have a larger profit. But when it comes to the internal rate of return, it's good to have a large internal rate of return to increase the margin I can work in. Okay, so if the IRR is 20%, you can have several types of investors that can be interested in your work. Even investors that have a high cost of capital, and even if an investor will tell you my A is 15% because I have other possibilities. I can invest in other projects and gain large amount. So I can impose on you a discount rate of 15%. Even if the discount rate is 15%, you can still work with a large IRR. While if the IRR is limited, this will limit the options of investors that you can work with. Okay? Is the idea clear, Batul?
Yes, thank you, Doctor.
Okay, welcome. Okay, now, as we mentioned, we can define the internal rate of return. Also, we can define, if you want, the rate that will give me the minimum acceptable CER. And all are indication, if you want, and the larger their values is, so larger the internal rate of return, or larger the rate of return for which the CER is acceptable, the better is. While smaller the discount rate, okay, higher the possibility of considering a project profitable, because this will increase my net present value. Okay, so now if we want to do the same calculation for project B, all we have to do is to first write the equation of NPV for B. So the net present value at year 8 for option B is equal to, so first for the cost, it's lower. Okay, we have the cost of the machine is minus 5,000. So this is the first favorable thing for option B. Okay, but the disadvantage is that now we have extra costs. We have an operational cost, so we have to pay for the employer $2,000 per year. So now when we calculate the cost per year, so we should now add summation from 1 to 8. First, concerning the revenue or income, first the productivity is smaller here because we have only 800 items per year compared to 1,000 items for A. So for the income, it's 800 times 4, which is the cost of item, which is equal to 3,200. So I have a 3,200 minus I have first the salary, which is 2,000. And I have also the maintenance cost, which is 2% of the initial investment. So minus 0.02 times 5,000. Over 1 plus a to the power I. And of course, don't forget the salvage value. So we should add, so plus 300 over 1 plus a to the power 8. Okay, so here, as we can see, the NPV is affected by several things. So first, the cost is in favor of plan B, okay, because we have a lower cost. But for the income is much smaller per year than the case of option A, because here this is constant. If we take it outside of the summation, we have 3,200 minus 2,000, and this is 100. So we just have per year a gain of $1,100. So it's much smaller, okay, than the case of machine A, but also, on the other hand, also we have a much smaller initial initial investment, okay? So because the number of years is relatively small, option B might be better, but larger, if we have a larger lifetime, this will give higher credit to option A, okay? And plus, also the salvage value in B is smaller than the salvage value in A because of the machine. The machine is more important in case of A. So what is the main limitation for A is the number of years. The number of years plus the high cost. Okay, so this is why we are not able to give an answer before we perform the calculation. So here, similarly, we can do a table in order to calculate the value of the internal rate of return. Okay, so we can do a small table, and for example, if we can start by time. Sorry for this. Do you hear me now?
Yes, doctor.
Okay, so
Yes.
now we can do a small table, and as usual, we can start with a certain value of A. Okay, so we have here A, and here's the NPV at year 8. So you can always start as 10% because it's a middle value if you want, and based on the value you get, you can decide if you increase or decrease. Okay, so for example, here we can start with 10%. We will find that we'll get a positive result, and so it's okay. So we should continue to increase because for 10%, we got a high value. So we can try 15%. Okay, if you try a rate of 15%, you will get NPV very close to 0. This means that the internal rate of return is close to 15%. And if you solve on your calculator, it's nearly, you get that the internal rate of return, no need to get it if you want 100% exact. It's fine if you give a certain approximation. And if you want to get it exactly, you can solve on your calculator. You will get for project B, IRR is 15.2%. So until now, if we just compare the IRR, we can say that the internal rate of return for option B is larger than the internal rate of return for option A. So until now, B is more favorable. Okay. Now, in order to be sure of our decision, it's not enough to compare the IRR. Already, we have an enhancement, but the enhancement is, they have, if you want close IRR, you have 11 point something for A and 15 for B. Of course, 15 is much better. So in case the net present value for B is also larger, of course, the CER, I mean, we'll talk about the CER. Why we don't just say the net present value? Because you should compare, if you want, you should consider the initial cost, the initial investment. You should take the ratio of the NPV to the initial investment to be able to take a good decision. Okay. So now let us calculate the net present value. The net present value for both options. Okay. If we to calculate the net present value for both options, we need the value of the discount rate. In this problem, they gave us. Do you see the screen?
No.
Okay, يلا just.
No, doctor.
Okay, يلا. Now.
Yes.
Okay. So now what we want to do is we want to compare the net present value at year 8. Okay. And we know now the discount rate. The discount rate is 5%. So all we have to do is we can use the same formula we developed before, but just we replace A by 5%, because in the previous calculations, the value of A was unknown. We want to determine A to calculate the internal rate of return. Now we impose the discount rate. And since it's much smaller than the internal rate of return, of course, we can expect that the net present value will be positive. Okay, but to calculate the CER, we'll divide it by the initial investment. So for option A, okay, the net present value at year 8 will be equal to minus 20,000. Now we can directly replace the numbers. So just it's 3,800 per year. And we multiply, we can directly use the expression of the summation, which is 1 plus 5%, so 1.05 minus 1 over. This formula will be given for you in the exam. You don't have to remember the summation. Okay, so over 1.05 times times 0.05, which is A, times 1.05, which is 1 plus A, to the power n, to the power 8. Okay, and plus the salvage value, which is 1,500 over 1.05 to the power 8. Okay, so if we calculate this term, we'll obtain the net present value for option A. And we get, in this case, 563.26, which is not bad, but to assess the CER, to check for the capital enrichment rate, CER, we should do the ratio of this over 20,000. So we do 5,563.26 divided by 20,000, we'll get 0.278. This means that the percentage of gain is 27.8%. Okay. For 8 years, it's not bad. For a period of 8 years, a gain of 27.8% is acceptable. Okay, but in general, larger the CER is, the better is. And if they tell you we want to ensure large CER larger than 30%, you say this is not acceptable. I can try if you want to get a better CER. If I tell you what can be the strategies here